So with this, we've concluded the warm-up lab. We should now all be ready to go. We should all now have access to the sandbox environments, and we can start with our first task, with the first lab, which is starting the pipeline. Now, how this works usually, this workshop is we'll go through the task which we're supposed to do, then give you a couple of introductory slides to the important concepts which we're going to use, and then we're going to go over to the sandbox environment and actually work on the task. So let's see how we can start a pipeline. Now, the first task is before we can push the application that our team wants to test, we have to do a few different types of things. We want to create a couple of pipelines to understand what best fits our needs, right? Obviously, we've been tasked with this because we're the GitLab experts and our product manager has high trust in us. So let's see how we can start the pipeline, test things out, and get things running. Now, the first thing that you need to know is about this script keyword inside of the pipeline definition. Here in the middle, we have a snippet of a pipeline. We have a job, which is called production. It's executed in the stage deploy function. And then we have a couple of script keywords. Now, the before script, what it does, it will be executed before the normal script keyword, but they run in the same shell. So it will be concatenated. Then we actually have the main script part. This is where we usually do all of the work. So the before script part could be something like a setup, which is needed for our script part, right? And the exit code of our script part will define if the job has succeeded or not. Now we also have after script. This is commonly used for cleanup tasks, for example, and this will run in a separate shell after the before script and the normal script keyword. The after script does not return, does not impact the success or failure of the job. So I already kind of mentioned job and stages. This is again displayed here, and I just want to briefly talk about the default execution order, so the default behavior. In here we have two stages, build and test, and in these stages we also have two separate jobs. So in build stage there's the build job, and in the test stage there's this test job. And currently what will happen is the test job in here will be executed after all of the jobs in the previous stages have finished. So it will currently wait for this build job. This is the default behavior. Now, I already said that these will be executed. Now you might also be wondering, okay, where's the hardware? On what is this actually running? And these jobs, they will be executed on GitLab runners. Now we're currently on gitlab.com. We are using the gitlab.com hosted runners, and there's a quite high variety of different runners. There's a lot of them. Usually it will just take a couple of seconds for a job to be picked up. And you can go even further. For example, what you could do, you could also host your runners on your own, maybe on a platform like AWS, and then you could enable auto scaling, which means you don't need to over provision runners. You always have the exact resources that you need. And what's also really important is to note that you can tag certain runners, and then you can use these tags and use them in your CI/CD pipeline configuration to make job run on specific runners. Just to show you how this would look like, on the bottom right-hand side, we have a little example. Now this job and tags and will run on this Ruby. Now it's also obviously possible to configure our runners a bit. For example, what we could do is we could configure it to use certain artifacts or to set up some cache settings. Like I said, we can use certain runners, we can protect sensitive information, but we can also set up job and script timeouts. There are many different things which you can do. GitLab like empowers you to find to configure this however you need to. We have great documentation there, so please feel free to have a look at that as well. Now, the one part that we're missing with GitLab runners is how are our commands actually executed, or how is this environment for the runners created. We have different kind of executors here. For example, we have an SSH executor. What this means is that the commands that we have, for example, defined in our script, under the script section, our CI/CD pipeline will then be run in our SSH. On the runner. We also have a bit more sophisticated things like the Kubernetes runners. What happens there is then a new pod will be created and the things will be executed inside, for example, a container in this pod. Which is great for autoscaling, for example, which I already mentioned. So this was already quite a lot of information, many slides. I think we're all here to get our hands dirty a bit of hands-on experience. So let's head over to our environment and start with the first issue. And what I would suggest you to do is maybe a similar setup to me. I have my group opened 2 times next to each other. And on the one hand side here, I will open up the instructions. And on the left hand side, what I will do is implement the tasks. So the first instruction in the Tanuki Racing CI workshop, just clicking on that. And in this issue tab. Now I have it pinned. If this is not the case for you, like I mentioned, you can also hover over this plan and find the issues there as well. And the first task that we are supposed to do is this simple pipeline. So I'm going to open up the issue here just by clicking on the name. And I'm directed to the issue with all of the instructions. Now, the first thing that we would want to do is obviously we are the ones working on this issue, so we want to assign this to ourselves. So I'm just assigning this to myself and then closing this right-hand side window again. So let's see what we are supposed to do. Now, we already have our project set up on GitLab.com, right? We are supposed to create GitLab's YAML file. Luckily, our colleague already had some basic definition for us. So what we are going to do is, I'm just going to copy paste everything so I can copy this to my clipboard. And on the left-hand side, I will go into my Tanuki Racing project. And I will head over to the Build tab and go to the pipeline editor. Now, there's already some definition there, but we already know that this doesn't work. We need something else. This is why we got this task. So I'm just deleting everything and then I'm pasting the contents of this file in there. So maybe let's have a quick look of what's happening here. First of all, we can see that we set up different stages. So we have the build and the test stage. And then again, we have the build job and the test job. The build job runs in the build stage and the test job runs in the test stage. Now in our build job, what we do is we have a before script. There we just do a docker info and then we also do a docker login with our registry user. And inside our script, what happens is we just do a docker build with this tag, which is defined in this variable. Afterwards, we do after script where we actually push this image to the registry, which we logged into. And this is a good example of how you might use the before script, and after script. So you do some setup, you actually do the work, and then you do some cleanup or some docker push in this case. So now if we have a look in the test job, there's currently just a script which is executed. We're doing some build pack, I don't know, some rules are defined, okay, all good. But what we want to do is we want to add an after script which echoes out that our racetrack has been tested. So what we can do here is we can simply copy paste this configuration again and insert this. Now it's important that we get the indentation right. So this should be right under the test on the same level as your stage and image, for example, or your script. Now, if you're a bit unsure, if you copy pasted correctly, you also have the entire definition for your test job here. So you can replace the entire test job with the contents here, and then you should be ready to go as well. But for the moment, we already made our first changes. We already created this pipeline definition. We added an after script and we are currently happy. So what we need to do is we need to create a commit message and actually commit these changes to the main branch. And here we already have a very good commit message so that I don't need to get creative. Just gonna copy paste this, and then we can keep the main branch and commit the changes. Now what happens is a pipeline is kicked off for us, and let's have a look at it, right? So you can either click on the pipeline ID, or you can also head over to build pipelines. Then you can see your pipelines and again, click on the pipeline ID here. And now what we see is, first of all, we have two stages, build and test, and also two jobs in there. Currently the build job is executing and the test job needs to wait until all of the jobs in the build stage have finished. So we'll just maybe give this a second. It might also make sense to refresh the page from time to time. And while this is running, what we can do here is we can actually head over to the second step and ask or use GitLab Duo Chat. So on the top right-hand side, you have this GitLab Duo Chat option. Now I'm just clicking it and it will open up the chat for me. So this GitLab Duo Chat is part of our AI functionality. This is trained on our GitLab documentation. So it's a perfect way for us to help us debug pipelines or ask about specific things, right? GitLab related, for example, but also coding or whatever you'd like to ask it. Now, in this case, what I'd like to run here is just a prompt, which we could use to ask what CI/CD keyword can we use to run commands after the job completes. So I'm just copy pasting this in, and let's see what we get here. Now, well, we got quite a fast answer, and we're just getting this after script. So this is at least what I was expecting as well. I hope after this exercise you also kind of expected this. And we get a bit of an explanation of what the after script will do. So you can specify commands that will be executed after each job. Okay, we already learned this. But it will also tell us how this might be useful. For example, we could use this for cleanup tasks, notifications, or any other actions which you might want to perform consistently at the end of a job. Then we get an example, which we can then include in our pipeline definition file. Or if we, I don't know, want to know more, we could also start a new prompt. I would recommend you, if you face any problems with your CI/CD file, or if, I don't know, if you just want to know or learn about something, use this Duo chat. You will have access to this as long as you have access to your sandbox environment. And yeah, it's a great way to experiment around. So, and right on time, perfect timing, I'd say, our test job finished as well. So the pipeline is passed, all jobs succeeded. So maybe let's have a look inside our test job. Now in here, we get greeted by a couple of logs. Maybe let's have a quick look. Now, since we, for this job, it was executed on this specific runner. So we get some information. We can see that currently we are using a Docker executor, and this is the image that was used. Also interesting, I guess. Then what happens? The repository is checked out, right? A couple of stuff happens. And we can see that, for example, here the after script is executed. So our racetrack has been tested, will be echoed out, and we see that indeed we get this on our log file, right? So it seems that our changes are working. Great. So with this, we already managed to finish the first task. So what we need to do is obviously scroll to the bottom. We finished this task, so we're going to press close issue. And I'm just going to do that. So now this issue is closed. We're done with it. So let's see what the second task is all about. And for the second part, we currently now saw like the default execution order, but since it's an advanced CI/CD workshop, right, we also want to tinker with maybe a bit more complex job execution orders, or we want to see how we can influence this, and also talk about direct acyclic graphs, so DAGs. So we showed off our amazing simple pipeline to the team. They loved it, but it's still not enough for them. They want more. So they were wondering, how can we speed up the process a little bit? Now, we are the 10x developers, right? We are the GitLab experts. So we decide, yeah, okay, let's show off our skills, impress them, and we want to create a pipeline with different execution orders as well as a DAG to show them what's possible. Now, if you remember, the current state of our CI/CD execution was that the test job had to wait before all of the jobs in the build stage finished, right? But now in this exercise, the desired state would be that we create a job in the test stage, which is called superfast test, but it should not wait on this build job because it doesn't depend on it. So it should start at the same time as the build job, but it should be still in the test stage because we want to, yeah, group similar things together, right? So how can we achieve this? And the answer is we can use the needs keyword. Now, with this needs keyword, what we can do is we can specify jobs which are required or which this job here is dependent on. So all of the jobs that we will list in here need to execute first and finish first before this code quality job here can even start. Now, this also means if we use this needs keyword and we specify an empty list, means that this code quality job does not require any other jobs. So it means it is okay for it to start as soon as possible, regardless of what stage it's in. Now, this is not all. It gets even more complicated, but shouldn't be a problem for us, right? We can also use the DAG pipelines. And what it will look like on the right-hand side here is that we have a pipeline definition. We have 3 different stages. And in there, we have different jobs. So we see build A, build B. They don't have a needs keyword specified. But in test A, we see that it only needs the build A job. Similarly, in the deploy A, it's only dependent on the test A job. Now, GitLab will look at this and then it will create like this graph for you. And in here, what we can see now is that the test A job only depends on the build A job, exactly like we defined it. So this means once this build A job finishes, test A job will start immediately. Doesn't matter what happens to build B. Like it could still be running, doesn't matter. Test A will still start. Now, there is also another concept which is called a stageless pipeline. So stageless pipeline, you get pretty much if you don't define stage, right? And you use the needs keyword to specify all of the dependencies. Now, why this might be useful is you can make your pipeline more efficient. You don't need to implicitly configure the execution order, so it's a bit faster to write. You don't need to fiddle around with the stages. And a more efficient pipeline means you have less cycle time, you might get faster deploys and bring value to the customer even faster. Now, this is available in all tiers and in every GitLab version, which is greater than 14.2. Now, I hope that none of you has to work on such an old version. Just as a reference, we're currently on 17.9. And by the way, quite exciting, in 17.9, we just released our self-hosted model, possibility for Duo. So what you could do with this means you don't need to use an LLM provided hosted anywhere else. You can host a model which you decide on your own infrastructure. So all of the data will stay in your network. Great. But let's maybe have a look at how the stageless pipeline looks like, right? So on the right-hand side here, we have, again, a pipeline snippet. We simply have a build job, it does some things. Then we have the unit test job. It just says we need the build job. And then we have a deploy job, and it's dependent on the unit test job. And how this will look like is pretty much like this. They all are now in this on the same level, so in the same stage now. Now GitLab always needs one stage. This is the default stage here. They will then all belong to this. But they will execute after each other, right? Now in a stage pipeline, which we've seen before, this might look like this. So we have the build stage, test stage, and deploy stage, and the different jobs in there. So this is the difference on the visual level. So again, lots of concepts. Let's get to the workshop instructions. So for me, I am still in the issue that we worked on before, which we closed. So what we can do here to get to the next instructions, we can, in the breadcrumbs here, just click on issues. So I'm doing this. Obviously, you can also use the issues tab here again, and you should see all of the issues which are still left to be worked on. And we are going to start with this second one. So number 2, execution order and DAGs. Same as before, we are the ones that work on this. So what we do is we are gonna assign this to ourselves. And let's see what we need to do. Now, the first thing which we like to do is, obviously, we are still in the track, we're still here in the job. And what we like to do is we just want to head back to our pipelines. So we're opening this here. And I'm just gonna click on the pipeline ID again to get directed to the to this pipeline definition, and we see that our jobs currently run sequentially, right? If you remember this from last time. Now we want to introduce another job which is called superfast test, and it should not run sequentially, right? We will add this to the test stage, but it should start as soon as the pipeline kicks off. So let's see how we can achieve this. And for this, we're heading over to the build and to the pipeline editor again. So I'm just gonna copy paste this and scroll down under the test job. I will just insert it. And let's have a look. What we do here, simply, it's defined to run in the stage test. We just do a simple script. So we echo if you're not first, you're last, and it's not dependent on anything. So this is where the needs keyword actually comes in. Now, this test job also doesn't require this build job. So what we want to do is we also want to add the needs keyword there. So I'm copy pasting this as well, just inserting it at the end of the test job, and I'm gonna make sure that I get the indentation right. Just adding this needs. So it should be on the same level as stage and script, for example. Now again, if you want to make sure that you get the indentation right, you can also just overwrite the entire test job with this definition here. But if I'm pretty sure you managed to do it, and we can just continue. So let's go ahead and commit our changes. So obviously, we need a commit message. So introduced super fast test, maybe something like that. We want to commit this to the main branch. And then I'm just going to click commit changes. And no surprise, another pipeline will be started for us. So let's have a look at that. So I'm just clicking on this ID again. And now what we can see, all of the jobs now started to execute at the same time. So the superfast test and the test jobs do not need to wait for the build job. And already our pipeline is a lot more efficient. So we want to take this a step further, and we want to introduce a DAG pipeline, right? And how do we do this? We do this by heading back over to the pipeline editor, so under build, pipeline editor. And we're just going to add another stage, which is called race. So we can just copy pasting this and overwriting our stage definition here. And then we're gonna add a lot of other jobs, which will then use this DAG approach. So I'm just copy pasting this, and I will include this below our super fast test job. Now we can see they don't have that they all have this needs keyword specified, and let's see how this will look like. Now, just to get an idea, we can visualize these things here on the visualize tab, so next to the edit tab, and let's see how this DHG looks like. So for example, here, if I hover over the test car A, what I can see is, what will be highlighted is all of the jobs that it depends on. So it highlights the graph. Similarly, now if I hover over this race car C, I can see that it needs test car C as well as build car C. But let's head back over to the edit tab. And what we want to do is, again, create a meaningful commit message. We get one here as well. So I'm just copy pasting this. And again, commit it to the main branch. And now let's have a look at the pipeline. So again, clicking on the pipeline ID at the top. And suddenly we can see that the superfast test and the test execute at the same time as always the build job. This is exactly how we configured them. And the other jobs, for example, the test car A waits for until the build car A has finished. So we see build car F just finished and immediately job test car F is kicked off. I'm just gonna take a second to fill up my glass of water again. But you get the idea now. This is how you can make your pipeline as efficient as possible. You do not have to wait. You do not have to make certain jobs wait for jobs which they do not depend on. You can speed things up with the needs keyword. Now, we already finished the second task here. So again, what we do is we scroll to the bottom and we close the issue. So let's see what our team has to say about this, right? And the next section, we are going to talk about a couple of other important concepts and maybe caching, which we can use to, again, speed up the pipeline. And we also want to be able to define rules which define when certain jobs should be executed. And also, maybe it's important to think about how we can handle failures in the pipeline. So we get back to our team, we show them our highly efficient pipeline, but the team still needs more. They ask us to make the pipeline even faster. Apparently, they're never happy with what we do, and it needs to be more resilient. So we know GitLab can help us by enabling caching through runners. For example, it can be used with S3 or with Google Storage as well, and we set off to fix this. So let's talk about the caching basics. On the right-hand side, what we see here is again a snippet of a CACT pipeline definition. We have two stages. In these two stages, we have two jobs. So in the first one, job A, we simply run this into build stage. I don't know, create a directory, and in this directory, we create this hello.txt file, which will contain the string build. In the after script, we will just echo out the word world. In our job B, it will be run in our test stage, and it will just do a cut. So it will print out content of our hello.txt file. Now, I skipped over an important aspect here, which is actually where we set up the caching. So in this default, this is pretty much configuration, which we can do, which will be attached to these jobs. So they can overwrite this, but if they don't, this is what they default to. And in there, we set up the cache. So everything that is in the vendor directory will be cached using this cache key. And also what we do is we execute a before script, which just does echo world. So let's think about the execution order of this. So at first, the pipeline will start. Then job A, because it's defined in the first stage, will be kicked off. Then the cache will be extracted if something is found in there. Then the before script is executed, which we define in the default here. So hello will be printed. Then the script part of job A will be executed where we create directory and file. The after script will be executed, so we just echo world. And then the contents of the vendor directory will be cached, so it will be zipped into cache.zip and saved in the directory, right? Using the cache key. So it is build cache. Afterwards, job B will start. So again, the cache is extracted, the before script is executed, then we execute the script part here. We don't have an after script defined in here. So again, it will try to, again, save the parts of the cache. Otherwise, the pipeline finishes. And this is the execution order here. So you might be wondering, why would you even use a cache? And oftentimes you might have certain content which you want to share between the jobs. Now, what you could do is you could just download this from any source, or you could build the content from any source in every job. But obviously, this is then work which you need to do again and again, and you just want to save resources, even if it's just network resources. So with this cache, it will like configure these content files, will sit closer to your runners. You will therefore have increased pipeline speed and again be able to ship your products faster and use less resources. Now, GitLab offers two concepts which might sound quite similar at first glance, which are cache and artifacts. And to give you an idea when to use one over the other, we have like two main differences. If your job isn't reliant on other jobs' outcomes, but it could be sped up by having access to them, you should use a cache. If your job is dependent on whatever was created by the previous job, you should use artifacts. Now, this is because you can't guarantee what's inside of your cache. It might be empty, I don't know, you might have cache miss, whatever. If it's dependent, use artifact. If it's just there to speed things up, it's nice to have using cache. Now there's also like a simple sentence which you could use to remember all of this, which is cache is here to speed up your job, but it may not exist, so don't rely on that. There's also a blog post, a great blog post, which will go into details about this. I think we could paste this in the chat, but again, you will get access to the slides after the webinar as well. Now, we also want to talk about how can we make our pipeline a bit more resilient, how can we handle failure. Now, you might have some jobs which you, in certain conditions or I don't know, whatever, might not care about if they fail. And what you can do there, so the entire pipeline doesn't break, is you can add this allow failure keyword and set it to true. Now on the right-hand side, where we see an example, we have the different stages, jobs, and currently we see this test B has set allow failure to true, and it also failed. We can see this because of the exclamation mark, but the entire pipeline doesn't break. So this is how you can set this up. Now, I already mentioned we want to be able to set some rules which define when our jobs are executed, and we can use this with these three clauses here. So what we can do with three clauses, we have if, changes, and exists. And what we can do, for example, is we can use if, then we can use an operator, for example, if the current commit branch is the default branch, so we would use like the equality here, then we want to execute it. So we kind of can use these keywords to build these conditions. We have equals, we have not equals, we have regex matching, and we also have and or. Then we also have these job attributes. So for example, what you can do is you can use when, this job should be executed, for example, when, on success, on failure, or you can also make it manual. So let's see this in action. Now, first of all, we want to give you some examples of when a job is not created or not executed in a pipeline. And there are 3 cases. The first one is if none of the rules that you define evaluate to true. So you define some rules, none of them evaluate true, it's not executed. The second one is if a rule evaluates to true, but it has the clause when never. So for example, here, if our pipeline source is the merge request event, then this job should never be executed. Third one is if no rules are defined, but a when never clause is specified. You just add this when never, then it will also never be executed. Now, how can we configure manual job execution? So you can do this by using this when manual. So on the right hand side, we have the snippet, we have a deploy job, we have script, and where we do our deploy, for example, and it should be manual. Now, you might be wondering, why is this even useful? Now, this is useful if, for example, you have certain protected environments and you only want certain people with certain permissions to be able to deploy to that. So for example, you have, I don't know, certain stakeholders for environments and you want them to be responsible for the deployment. So you could set this up with when manual, and what would happen is they would then need to head over to the pipeline and press this play button. Then this job would be executed. It's also possible to delay a job run. If, for example, here, what you can do is you can use the when keyword delayed, and then you need to use delayed or start in, and you can specify a time frame. This example, you want to delay this for 3 hours in this example at the moment. It's also possible to conjoin these clauses, so if changes exist. Now, if you, like in this example, you put them together, so we have an if and we have changes, what will happen is, first of all, it will look, is the content of this variable the string value? If this is true, then it will look at the changes keyword, which means the job will be included. If any changes were made to files or directories which match these patterns here. So as you can see, this is an AND. So if you use them in the same rule, you will concatenate them with AND. If you create multiple rules like we saw before, it will be concatenated by an OR. And this is how you can build your more complex flows. Now, let's see how this looks like in action. So I'm heading back over to my sandbox environment. And first of all, we want to head back over to the issues again. So I'm using the breadcrumbs. And I'm going to open up number 3, caching rules and failures. As always, we want to start off with assigning this issue to ourselves. I'm closing this again, and let's see what we are supposed to do here. The first thing we want to do is reset our existing pipelines with all of the DAG jobs that we have in here. Now, how do we do this? We head over to build and the pipeline editor. Now, we could delete all of these jobs manually, but also at the bottom, we have the pipeline which we should end up with. And I'm a bit lazy, so what I will do is I will just copy paste this, delete everything and paste the definition in. Now, we reset our pipeline and we are ready to start adding some rules. And the first rule which we like to add is to our test job. And we only care about this test job if it's being if, for example, the job that's running is being merged into main. So if the current commit branch is the default branch, then this should execute. So I'm just copying this to my clipboard, heading over to the test job, and making sure I get the right indentation and copy paste it. Now this test job will only be executed if the current commit is on the default branch. But we are not done yet. We also want to add caching because it should be more efficient and we allow failure to make it more resilient. So if we remember back, we saw that the last pipeline took quite some time to run. And this is because a lot of the configuration that we needed had to be downloaded or created over and over again. Now to fix this, what we want to do is we want to add caching to this vendor Ruby and gem file log. So this is what's needed by all of the other jobs. And it's quite simple to do this. We just need to copy paste this definition and then I will explain what it does. So we'll head over, we scroll to the top and under our image definition, this is where we'll insert this. And what's happening here is we set up the caching. We set up a key, which is cache minus our commit ref slug. We also add some fallback keys for cache misses, and then we will add everything that's in vendor Ruby and the gem file log. So now this gets cached. Now in our case, since GitLab.com is built on Google infrastructure, what we will use here is also an Google Cloud storage for this caching. So the only thing that we're missing now is to make our pipeline more resilient and adjust for failure. So in our super fast test job, currently we don't care if it fails under certain conditions. Now to force this job to fail, what we will do is we will add this exit one, like I mentioned earlier. The success of a job is defined of what is returned in this script. So just adding this exit one. So it will fail, and now we can go ahead and say that what we want to do is this super fast test job is allowed to fail if the CI commit branch is our default branch. So if we are on the default branch which is main, then we want to allow the failure. Now just to make sure that we got the indentation right and everything, I will just copy paste the entire super fast test definition and overwrite it. So we've made the changes. Now again, we're missing just the commit. So I will again copy paste commit message here, insert it, and commit it to the main branch. Now you all know by now what's happening. A new pipeline is kicked off, and let's see what we get there. So again, I'm clicking on the pipeline ID, and I'll be redirected to this page. And here I will just give it a second for the jobs to run. Now, I don't know, Sarah, do we have, by the way, another survey which we could run at this point?
We do have the poll in regards of the timing, but I guess we can start it now, but we can also wait because I think after your exercise there is a little break anyway.
Yeah, okay, that's good. But now we see that we already get result. We see that the super fast test job failed with this exclamation mark. We already see again which runner was selected. We're using the Docker executor, then the image gets pulled, and we simply do this exit 1 and we see job failed because the exit code was 1. So this is exactly what we wanted. Now I'm heading back. This failed with exclamation mark, but our pipeline is still running. It's not broken. This is the part which I wanted to highlight here. And perfect. Now, at least for me, all of the job have passed. So let's maybe have a look at the test job. So, and what we see here, again, we select runner, Docker executor, all of that, okay. And we see here that we're checking the cache. Cache file does not exist, makes sense. And we then start executing our script. And at the end, we are running the after script. Our racetrack has been tested. And we see that we here start saving our Ruby file into the cache. Cache was created, job was succeeded. And what we learned is we can now allow failure with certain conditions. We can cache things. And we made our pipeline more efficient. So again, we finished the section. So I will close this issue. And this also finishes my part of the workshop. I think it would be great if we could take a small coffee break. I'd say that we'll meet each other in 30 minutes because at least my time then it's 11:20. See you then. Thank you for listening so far.
I will also start a poll to make sure that if everyone can follow along, so you should see that in a second, so that we know if we speed it up or if it's too fast, too slow, and then we can work with that accordingly. Okay, I'll put on some music and then we will see each other at 11:20.
You did it.
Hello, hello, hello. I see
Welcome
that
back.
only 26 people have answered the poll yet. So if you've not done that yet, this is your last chance to do so.
Okay, since some of the participants answered the poll asking for slowdown, I will try to slow down a little bit. I will force myself to read more in order to go down, to go slower. So let's briefly recap where we are. Let me share my screen. Okay. So Florian built a pipeline in which there are two stages, the build and the test one. In the build, there is a job called build that is now also caching some stuff inside of it. And then in the test stage, we have done, we forced the super fast test job to fail, but not to block the pipeline, allowing so the pipeline to go on. Okay, so here we are. Let's switch to the presentation and let's start the fourth lap of this race, talking about components, templates, and artifact. So we have now started to build our beautiful pipeline, but we want to be sure that we that we leverage the full advantages of the wonderful feature that GitLab offer to our customers. So let's start to introduce some nice concept like the security scanning. The security scanners are those scanners that can help developers to reach out vulnerabilities in the code, password inside the code, so sensitive data, and so on. There are many of them built in GitLab. I can tell you the SAST, that is the static application security test. That is the scanner that looks for vulnerability inside the code before the building phase. So it acts as a static analyzer. There's the DUST, that is the dynamic application security test that try to look for vulnerabilities calling the API. There are a ton of them, but let's start with the first one. But first of all, I have to introduce a couple of concepts that are components, CI/CD components, and CI/CD templates. I have to introduce this concept because we will use templates and components in order to include those security scanners. So what are CI/CD components? They are similar to CI/CD templates. We have recently released them, but there are some key differentiation with the templates, because they are released like a true app, so with versioning code inside, that they can be directly passed variable through, like an input parameters. So you don't have to leverage to variables. You can pass the inputs directly. They are easy to test because they are a real application. So you can do everything that you can do with a normal application. And they are far better to discover because there is a kind of marketplace in GitHub of components in which you can look for any components already developed. These are some example of already existing components. Some of them are directly maintained by GitLab, like SAST, for instance. Some of them are maintained by a partner, like Cloud Run, and some of them are community maintained. So, as I mentioned before, there's a sort of a kind of marketplace. We call it the CI/CD catalog, in which you can look for any components already already done, and it's really easy to include them in the pipeline. I will show you in a couple of minutes. So we have talked about the components. What is a template? Similar to a components, is really there's no magical behind the templates. It's just a piece of pipeline. It's a piece of a CI/CD YAML file that you can include in your pipeline. So it's the way to share CI/CD capability with other teams in your organization. It's the way to consume CI/CD capability from other team in your organization, and the way that GitLab engineering provides capability via templates. So you will find some predefined templates from our engineering, but you can build your own templates and include in your pipeline. Okay, so this is the way we can include a template. We have to use the keywords include, then specify a template, for instance, the one for the SAST already developed and built in GitLab is the jobs/SAST GitLab CI.yml. So you can easily include any kind of template in your pipeline, simply adding these keywords. Then you can customize, of course, the template using some variables, or you can also overwrite some capabilities of the template. Other way to include the templates are using the local keywords. So you can include another template in the same project, so in the same repository, maybe in another directory. You can include a file from another project in the same group. So you can have different projects in your group with different pipeline. You can include a pipeline of another project using the project keyword. And then you can include also a YAML file located in another repository, also in another GitLab instance, but it should be public available, of course, using the keywords remote. So you can include a template, a local template, or a shared template in another project, or a remote template. Okay, as I mentioned before, you can also customize the behaviors of these templates. And there are several ways to do this. You can simply add some variables. Every template use normally variables to customize the behavior. So you can define this behavior using variables, or you can overwrite some aspect of them using the keywords extends, like this. Okay. Please be extremely careful using variables, because sometimes you can put in the variables some sensitive information. So always mask or protect this variable using the mask capability in GitLab, or if you wish, you can use an external vault to be sure that every secret is kept safe. Okay. Another topic, a really important topic regarding variables, is the processing order of the variable, because you can put variables values in many places in GitLab. You can put in the project, in the group, in the instance, in the pipeline, or when you run the pipeline, you can specify a value for variables. So you can put variables everywhere, and what is important is to know the order, the processing order of them. GitLab starts. We can say that the precedence of this order starts from what you put in the interface manually, then the values configured at project level, group level, and instance level, the values inherited from a previous job, the values that you put directly in your YAML file, or the predefined values for those variables. So keep in mind this processing order. Okay, another topic of this exercise regards what is called build artifacts. Once your job is finished, you have the ability, we have already seen the cache ability, but there is also the possibility to store the output of the job in the form of an artifact, and to store this artifact in GitLab for a certain amount of time. You can define this amount of time using the expire in keywords. After this amount of time has passed, the artifact is removed by GitLab. But you can always have the ability to keep this artifact despite of the expire time, clicking in the keep button at the job detailing page. So once you click the keep button, the artifacts will stay beyond their expiration. Okay, so once you have an artifact, you can download the artifact in several ways. You can download the artifact in the pipeline page, for instance. You can download in the job page, so the exact artifact for that job. You can download in the job detail page near the keep button. And there's also another section in GitLab for near the registries, so near the container registry. It is called the artifact browser, and you can browse all the artifacts in that session. Okay, so let's try to make some nice things in the exercise. So, okay. So let's move to the exercise. Okay, we are at the exercise number 4. And we can, of course, assign the issue to us, as always. Okay, the first thing that we can do is to look for root cause analysis of the last pipeline. Yes, we can click on the super fast test job. You remember we forced the job to fail, putting exit 1 as a result code. But what happens if we want to troubleshoot this problem? With GitLab, we have the ability to click on the troubleshoot that is located in the bottom of the page. Just clicking the button, you can see that the GitLab Duo chat will appear, and GitLab simply answer to our question to troubleshoot. As you see, in this case, GitLab recognized that we put exit 1 as a result code. So GitLab Duo provides also a simple fix, that is to simply remove this condition. And this is a really nice way to troubleshoot problem in your jobs, because it can happen that something goes wrong. Okay, so this is a really nice feature to troubleshoot our problem. Now let's go back to our pipeline editor. So let's switch under build menu, pipeline editor. Okay. And yeah, let's see. So we have to navigate back to our pipeline editor and click pipeline editor button. Yes, of course. And we have to change the return 0 instead of return 1 in the super fast pipeline. Yes, so let's try to fix this in this way. Okay, then we have talked about CI/CD catalog. So what we want to see in this exercise is how to see the catalog. You can find a button called CI/CD catalog at the top of the pipeline editor. If you click on the button, GitLab redirects you to the catalog. And here is where you can find all the components maintained by GitLab or partner or community. And as you see, you can find you can look for instance, SAST. Yes, this is the one that we want to use in this exercise. We can click on it. We can see all the inputs that you can pass to these components in order to change the behavior of the components. And yes, and GitLab also suggests you the way to include these components in the pipeline. So really, really easy. Okay. So let's try to add this SAST component to our pipeline. Let's go back to the pipeline editor. Let's copy this piece of code and let's put this piece of code just above the variable definition. So exactly here. Okay. So what are what we are trying to achieve is to include in this pipeline other jobs coming from the SAST component and see how they are integrated in our pipeline. As you see, it's very straightforward. It's easy. It's just a matter of include a component. As we see, we can also change the behavior of the component, adding some inputs. And in this case, since we want to achieve a greater level of depth of our SAST scanner, we can add this input that specify the search max depth. That is simple, how many folder you have to go in depth. So pay attention to the indentation. Okay. There is some indentation. Let's copy. Okay. Yeah, you have to be below the components. Okay, so we have included our component. We have specified our inputs for it. Let's try add some more component. But before this, I want to show you a nice feature. If you go to the top of the page near the branch selection, there's a kind of tree. If you click on it, you can see the list of all external components that we have included in the pipeline. As you see, there is the main pipeline and the SAST component that we have already included. We can also see what is the full configuration of this pipeline, clicking on the full configuration. Clicking on this, you can see that there is a merged configuration of our pipeline definition and the one defined in the component. And you can see so the result of this merge of the full configuration. There are many stuff. Okay, if you go in the visualize, we can see what are we including using these components. So after the build in the test stage, as we see, there are many versions of SAST, one per technology, you can see. And so this is the way we can include our components in our pipeline. So now we have added the SAST component. Let's also try to add the other two scanners, the dependency scanning and the secret detection, to our pipeline. The dependency scanning is a scanner that scans for vulnerability not inside the code, but inside the dependencies of our code. So if you have, I don't know, a Java project with a Maven file, with a POM XML file, there are many dependencies inside of them. This scanner looks for vulnerability in those dependencies. The same for the package JSON of a JavaScript project or pip for Python. I don't know. There are many of them. So let's copy paste this block, and let's include also the dependency scanning. And the secret detection is easy to understand. It's a scanner that looks for secrets inside the code. The secret detection scanner looks for the secrets in the code, not only in the last code, in the last commit, sorry, but in all the history of the commits. You can specify also the depth of the history. So it's a very, very nice scanner. Okay, so as we see, we can also check that dependency scanner and secret detection are added to our dependency tree. Yes. And what we can do now is to change to override so the behavior of some of the components that we have included, and for instance change the stage of the components. Do you remember now all of the components are in the test stage? Maybe we want to change one of them, the secret detection one, and put it in the stage security. So what we can do is to simply copy this block and we can yes, put at the end of the pipeline. So we are what we are saying to GitLab is that our secret detection components belongs to the stage security, and it can be run without any dependencies, so it can start as soon as possible. But we have to also define the stage, because at the top of the file we have only the build and test stage, so we have to add also the security one. Okay, and let's see what's happened. Yes, if you click on visualize, you see that the secret detection moves from test to security stage. Okay. Yeah, before committing, we want to also try to play with the artifacts. So it's really easy to say to build an artifact, to store the artifacts in GitLab. Simply add the artifacts keyword at the end of a job, and the game is done. So let's copy this piece of code. Let's come back to the build stage. Let's rewrite this part. So we are telling GitLab to store all the artifacts beyond the path of gem.lock, so this file, and that those artifacts should be expired in 1 hour. That's all. Okay, so now we can finally commit our pipeline. Let's copy the comment, put in the file, and press commit changes. Likely we will have a new pipeline starting. You can click on the top of the page or go to pipelines. Okay, here there's the new pipeline. Simply click on the running button. You can see our new pipeline. So we are waiting for the build phase stage to complete, but our super fast test and test is has no dependency like the secret detection one, so they already have started. Secret detection is already finished, and we can see in the build job. Yeah, we have to wait for the job to finish, but at the end of the job, we can find here a button to download the artifacts. We can download the artifact produced by this job. As I say, we can take the artifact in this section, but we can also take the artifact in the pipeline section. You see there's a button downloads artifact. We can also go directly in the pipeline and look for the job that we want to we want to look for the artifacts. For instance, you can go to the secret detection and you can see there are the section job artifacts. We don't have artifacts in this section. We have to wait for the build one. Oops, sorry. Okay. Build completed. As you see, you can download your artifact simply clicking by download. If you click on the keep button, the artifact will never expire. You can also click for on the browse button to go to be redirected in the artifact download page. As you see here, we have the gem-block file that we ask to be stored as an artifact. Okay, so let's see if the pipeline is finished. Oh, not yet. Yes, just in time. Okay, so let's see the result. The build phase, the build stage is completed. Then in the test stage, we have a couple of security scanner in the test stage. You can see the dependency scanning here, the SAST scanner here, and the secret detection here. If the scanner found some vulnerability, you can find the result of this scanner under the section security. So under the section security, you will find all the results of all the scanners. You can see there's a column called tool with the definition of the scanner that reached that result. You can filter, of course, for any kind of scanner. And maybe this is the end of this exercise. We can close the issue, clicking on close issue, and let's go to the next stage. Okay, so let's come back to our presentation. So another lap of this Tanuki race. Now we will talk about child pipelines. So let's imagine we will want to add several scanners, maybe some of predefined scanner, some other custom scanner. I don't know. You want to add a lot of things in your pipeline, but you decide to not put on the same pipeline, but to create another pipeline with all the security stuff related in that pipeline, and to link our pipeline with the other one using a sort of a kind of a parent-child relationship. This is exactly what GitLab means when it talks with downstream pipelines. So downstream pipelines enables multi-pipeline CI/CD setups. You can link different pipeline each other, allows for different ownership of different parts of the pipeline, and can have the child pipeline depend on results or generate YAML from the parent pipeline. We will see in a couple of minutes. There are two types of downstream pipeline. The first one is the parent-child. The parent-child has the limit that pipelines should exist in the same project. So we are calling another pipeline in the same project under the same commit. So they are strictly related in the same project and in the same commit. And you can have max depth of 2 child pipeline in the same pipeline. Another possibility is to use the multi-project downstream pipelines. In this case, pipelines exist in different projects, so you are calling up, triggering a pipeline of another project. And the overall status of the pipeline affect the single pipeline, but not the overall. We can modify this behavior, and we will see. But yeah, let's take in mind that parent-child are strictly related, while multi-project are typically independent. Okay, so there are no nesting limits in multi-project pipelines. Okay, of course, you can define several rules when you trigger a pipeline. You can, for instance, decide to run a triggered pipeline if we are on a merge request, for instance, or simply in a pipeline, or in both of them. The key is to add the rules keywords specifying an if condition. For instance, in the job 1, we can see that this job will run only in a multi-project pipeline. In the job 2, with this condition, the job will run only in a merge request pipeline. And in job 3, we have both of them, both of the condition. So you can play with rules in order to have a different pipeline to start when triggered as a child pipeline. You can force also an overall failure of the pipeline using the keyword auto cancel and with the on job failure value to all. In this case, as soon as one job fails, all the entire pipeline will cancel. This is useful in a job result dependent pipeline, and we can also use this condition in a downstream pipeline or parent pipeline if both parent and child pipelines are set up to auto cancel on job failure. So we have to put this condition in both the pipelines. Or if the child trigger job is configured with strategy depend. So, oops, sorry. So if you put this or this in both of them, the auto cancel feature is enabled. Okay, let's move to the exercise. Exercise number 5. So let's come back to issues, or let's go under plan issues if you don't find the pages, and click on the issues number 5. Let's assign to ourselves the issue. It's normal. Okay, let's switch to the pipeline editor. So your security team got wind of all of the security scanning you added to your pipeline and wants it to be added to a new pipeline that they have access to and can control which jobs are run. To do this, we are going to create and link a child pipeline from our existing pipeline. In this case, we will just be adding the second pipeline to this project, but it could have been added in a separate project and have been linked. So we will create a new pipeline in our project and link the main pipeline to the second one in a child-parent relationship. So let's start to do this. Let's click on Edit Web IDE. So we have to come back to the main page of the project. You can see a button called Edit on the top, and you can click on Web IDE. This will open a new tab in your browser. Yes, with a web browser-based IDE. It's a simple ID with all the file of your project. We are currently on the main branch. You can see the branch on the bottom. We can use this GitLab feature to modify several files and commit at the end. So what we now have to create is a new folder called security pipeline. So let's create this folder. Simply click on the browser, on the new folder, of course, copy paste the value, and we have the new folder created. Within this new folder, let's create a file called security.gitlab.ci YAML. So new file. Okay. And now let's put some content on it. Copy paste this on this. So let's see what's happened here. So in this new pipeline, we are including the SAS components with the same inputs of before. We also have added another input that is run advanced SAS equals to true in order to say, hey, don't run the basic one, but run the advanced one that is a security scanner included in GitLab Ultimate. And then add also the template for the dependency scanning and security detection. Okay, as before, security detection will be in stage test this time, and it has no dependency. So we are simply moving part of the pipeline in another pipeline, in a new pipeline. The reason why we should do this is, for instance, that this pipeline is in another project maintained by another team with other responsibilities, with other also knowledge, I don't know. So we can separate the pipeline in different files and then include with the trigger keywords. Okay. The pipeline now has all it needs to run our security test. Once added, click on the source control button on the left and commit to main using this commit. So what we have to do is to click on this icon, put a commit message, and simply click on commit and push to main. You will be asked to confirm. Yes. Okay. Now we can close this web video and come back to our workshop. A new pipeline should be started as soon. Yes, it's already started. Okay. Let's see what's happened. In the main pipeline, we don't have a change. We have changed nothing. So the result of this new pipeline should be the same, because we have just created a new file in a new directory, but we don't have already linked with the main pipeline. So let's try to link now. Let's come back to pipeline editor. Okay, and trying to link the new pipeline. So at this stage, we should have something like this. If you want, you can also copy the entire pipeline and overwrite your pipeline just to be sure that we are all on the same page. Yes, and what we have to do now is to add another stage called the extra security, in which we will link the external pipeline. So, oops. Okay, so add the new stage, extra security, and also add a new job. We can put it on the bottom, the pipeline definition. Okay, let's see what's happened. So we are defining a new job called downstream security. The name of the job is something that you can define as you want. In the stage extra security, and what will do this job will trigger the pipeline file that we have already defined in the security pipeline folder called security.gitlab.ciml. So this is the way you can reach a simple child-parentship relationship with an external pipeline in the same project. Yeah, so let's commit this change using this commit message. Put the commit message in the commit message box. So we are refactoring streamline main pipeline and link to a child pipeline, commit change. Before commit, we can also visualize what will happen. Yeah, as you see, there is a new stage called extra security with a new job download security. Let's see what happens when we commit this change. A new pipeline will start. Here is the pipeline. Okay, so let's see. You can see that there is a new stage, the extra security one, with a downstream security job with a label trigger job. Once the build and test stage has completed, the extra security job will trigger the external pipeline, the file in the pipeline, the external file in the child-parent relationship. So meanwhile, the pipeline goes on, we can now close the issue because we reached the end of the exercise. Yes. So we can close the issue. Okay. Let's come back to the issue list. We have just one exercise more to be completed. Can open it in the meanwhile. Let's come back to this. Just wait a couple of minutes. I want to take your time to review what we have done. And in the next exercise, we will make a really funny things called the dynamic pipelines. There is a kind of inception because we are using a child-parentship relationship to trigger another pipeline that is not defined at the when the pipeline is started, because the child pipeline will be defined during the pipeline itself. So we will launch a dynamic pipeline. Anyway, let's try to refresh this page. Yes, we have to wait just for the test job to wait. We can click also on the job and see what's happened. It should finish in a couple of seconds. Okay. Let's go back in the in time. Oops. Go back. Yes, we have to wait for the test to finish. Okay, I think that we can also start with the next exercise, just to not wait too much. I'll give you, okay, job completed. Perfect. So let's see. The test stage is completed. The extra security stage start. The downstream security job trigger the external pipeline. And as you see, there is a downstream pipeline, the child pipeline, that is running, and the content of this job is the content that we have defined in the other file, in the external file. So this is a simple way to first of all split responsibilities of the pipeline, but also to call a pipeline of another project, or I don't know, or of another public repository. Okay, let's switch to the presentation. So, last exercise, last lab, dynamic pipelines. As I mentioned before, we want to have the possibility to generate the code of our pipeline during the pipeline itself. So let's imagine we want to create a pipeline that has knowledge of the, I don't know, variables or precondition or other jobs of the pipeline. So we can sum up all the results of the pipeline and use some, I don't know, some scripts to create a new pipeline and save the scripts, save this pipeline in a file, store the pipeline, the file as an artifact, and then in another job, use this artifact as a child pipeline. This is what we will do in this exercise. So what are dynamic child pipelines? They are they trigger a pipeline from a YAML file that was generated by another job. So in a job, you will create the pipeline, and in another, you will trigger that pipeline. They are great for creating dynamic workflow to react to when target content changes based on our pipeline. And they are built of our artifact capabilities. So this is what we will create. We will create a job that as a script, the generate CI config script, whose output will be stored in a file, the generate config YAML file, and this file will be stored as an artifact at the end of the job. Then, in another job, in the child pipeline, we will trigger the execution of another pipeline, this time not referencing a file, but referencing the artifact produced by the previous job using the keyword artifact. Okay, you can specify, of course, the name of the artifact and the job that produced that artifact. In this case, generate config is the name of this job. There's just one limit for this kind of approach. That is the maximum size of the artifact. That is 5 megabytes. So let's come back to the exercise. Okay. Let's assign to ourselves the issue. We can see that the previous pipeline has completed. So we have correctly launched a downstream pipeline. And let's start to create this new script. So first of all, come back to the project, clicking on the main project button, reopen the web IDE. Remember, click on Edit, Web IDE. Okay. Once you are on the Web IDE, let's create a new file that will be the script that will produce the pipeline. Let's call it pipeline YAML creation.sh. So just click on new file. Put the name of the file, of course. Copy paste the content. You can click on here. Let's see what's happened in the script. So we are using the cat functionality of Linux system that is simply to print out the content of the script. The script starts with the definition of the image, then include, of course, the SAST components and the template for dependency scanning and serial action. So it's the same script that we have done before, but this time we will print out this script in a file during the pipeline, not before the pipeline. So you can work with your fantasy and create a beautiful script that makes a lot of stuff using, I don't know, also, why not, code of the repository, produce some output and save in a file. Okay, now let's commit this new script using the commit to main button. We have to click on the source control icon, paste the commit message, and click on the commit and push to main. Okay, we can go back to the project. We can close the IDE if you want, no problem. And let's go back to our pipeline definition. Click on pipeline editor. Okay, so now we have in our project, I can show you also in this way. We have created a new file called pipeline YAML creation.sh. You can find it on the main branch on the root of the folder of the repository. Let's try to use this script inside our pipeline. So come back to pipeline editor. Let's go to downstream security. Okay. Remove the downstream security that we have added before, because we will make a new one. Remove also the extra security stage at the stage level. Okay. Then copy paste the new definition, and let's see what we are pasting in the pipeline. So we are adding a new job called dynamic security build job in the stage build that simply run the script. So it's check-modding the file with execution privilege, and then simply execute the pipeline YAML creation .sh. So we have seen that this script will produce a file called security config, and then we want to store that security config YAML file as an artifact. This artifact is then be used in the other job as a pipeline triggered by the stage dynamic. Probably we have to also add the stage dynamic at the beginning. So let's copy stage dynamic. Let's come back to stage definition, stages definition. Oops. And let's add the dynamic stage. Okay. So we have a new stage, dynamic, a new job that will trigger a new pipeline whose content is defined in an artifact coming from the previous job. Okay. We also have added the strategy depend in order to have a direct relationship of the dependency. Okay. So we can copy the commit message and paste on the commit message box. Click on commit changes. And let's see what is happening now. So as before, in the build stage, we now have the build job and the dynamic security build job. Remember, the job is the one who will create the artifact. So in this job, there is the execution of the script. The script produces a file. The file will be stored as an artifact, And then at the end of the pipeline, we will use the trigger functionality to trigger the new pipeline coming from the artifact stored by the dynamic security build job. Okay, let's see what's happening in the job. Okay, as you see, at a certain point, there is the execution of the script. The script will produce a file that will be stored as an artifact. You can see here. We can see also that the artifact is in the artifact folders. So this is we can also see the content of the file. We have to download it. Let's skip this step. Okay, we can come back. So the artifact has done. Let's wait for the dynamic security run job to start. And if everything goes well, okay. So we have our dynamic pipeline generated by an artifact, generated by a job and stored by an artifact, and then dynamically launched by our pipeline. So with this exercise, we have covered mainly most of the way we can use the downstream pipeline. So we can include a local file. We can include a file on other project in the same group. We can include a file of a public repository, and we can include a file coming from an artifact in the same pipeline. Okay, so let's close this issue. Yes, and let's come back to our presentation. So with this exercise, we end up our workshop. And if you want to transfer the project that you are using in your sandbox, you can find the instruction under the courses transfer project folder. Let's see together. So you can go to the courses folder, transfer project, and follow the instruction here. So you have a certain amount of time to use the sandbox. Once the sandbox will be closed, you will lose the project unless you transfer the project to your GitLab instance. Okay. So maybe it's all for today. I'll pass the ball to Sarah for the conclusion. Thank you so much. Sarah? With Sarah. Okay.
Yes, we are missing her.
No problem at all. So I hope that the workshop is going well. I try to go slow to slow down my speed. I don't know if I reached the goal. Yeah. Anyway, I think that we can make the conclusion without Sarah.
Oh, I can take it
Okay.
off, but I don't have access to the slides. So this is where, Sarah, are you back online?
Yeah.
I hope so.
Yes.
Let's see. I think it was just a little hiccup.
No problem, Sarah. Thank you.
Oh, she's gone again. So we are going to open it up for Q&A. If you have any questions, please can you add it to the Q&A chat, and then we could read it out and any of the essays can pick it up and answer.
Let me share the presentation, Seraphine. Yeah.
Can you go back to the Q&A slide? There's a slide before this here. So there's a few questions in the chat. I will read them out and anyone can pick them up and answer. So someone has a question, says, first of all, thanks for great content and task. I have a question regarding CI/CD job execution order. Imagine I need to control order of CI/CD job execution based on the triggering commit order, i.e., there are a few branches, feature A, feature B, feature C. They get committed in sequential order, one after the other. So goal is to execute all the jobs belonging to the pipeline. And if they are getting merged to the main branch as well, so go sequentially from the first commit, from first commit before starting with jobs belonging to the next commit in the historical order. Is that possible? That's a long one, but
Okay.
let's see. Can understand it.
Perhaps imagine I need to enter order for a job execution based on the trigger commit to order. Yes. There are a few branches. Okay. Okay. We are talking about different pipeline coming from different commit and different branches, if I understand. And yeah, if this is the context, you cannot govern the order of the pipeline execution, because the pipeline are executed once you commit something on your branch. And at that time, there is a task in GitLab pending, and the first runner that take care of that task will execute that pipeline. But yes, runners are asynchronous in their way to act. So you can govern what happened inside of the pipeline, but not the order of the pipeline if they are not related in a child relationship, child-parent relationship. I don't know if I got the question.
Yeah.
I think
Another-
one thing to add here, one option that you could consider is you can also call the GitLab API from within those pipelines. So
Yeah.
it would involve some scripting, but what you can do is you can check for earlier pipeline runs. You have access to the predefined CI variables, and there's one for CI API token that you could use, and then get access to currently running pipelines and their status, then define the start time and then execute them. But this would involve the dynamic child pipelines that Francesco showed earlier. So there's no native way, but with some scripting, you might be able to achieve what you're looking for.
Yeah, maybe there's also another way, but I don't know. You can force the behavior of the runners, putting the parallelism to one. But yeah, I mean, you have to have the ownership of your runner. Ask the runner to make all the pipeline in sequential way, putting the parallel value to one. And so in this way, there are no no more than one pipeline going together. But I don't know if this is a real solution, because then everything will slow down a lot.
Any other questions? I see that this one was answered. Yes. So you just replied, yep, they already limited to 1, but I still see sometimes they starting jobs from next branch before finishing all jobs from the first commit. There is one article that I would like to share. Let me see if I can find it, about pipeline efficiency. That might be helpful for this use case as well. Let me see. Yes. One thing that you could consider is also take a look at the interruptible keyword, which will stop pre-existing pipeline runs. Here, I'll share the link within your answer. It's in general, it's a great article. I'll also post it in the chat in regards of pipeline efficiency, when pipelines run, how you can make sure that, for example, merge request pipelines only run on merge requests and you don't have duplicate pipelines because of the branch pipelines and so on and so forth. I'll post the link into the chat.
Okay, there's another question from Santi asking, which one will you recommend, self-managed GitLab or SaaS for the organization with 100 employees? So this highly depends, obviously. So with the SaaS version, you don't need to worry about managing your GitLab, right? So this is all handled then by us. With SaaS, it's multi-tenant, so you will be sharing resources with other opportunities, but you have your own separate namespace. Now, sometimes this is a reason why organizations then decide to go the self-managed route, because then you have everything in your resources, but and you can customize everything, set up everything the way you'd like. But then again, you would have to manage it yourself. Yeah. So I guess this depends on your needs.
Yeah. One common use case for self-managed versus SaaS is that GitLab SaaS is hosted in the US. So if data residency is a topic, SaaS might not be the option depending on where you are located and where the data needs to be hosted. So if you're looking for example, an EU instance, self-managed would be the best option. We offer self-managed GitLab instances that are managed through partners of ours. So if you don't want to self-host because you don't have the capacity, but you can't use the SaaS version, please feel free to reach out to the sales team and they can connect you with a partner that can host the GitLab instance for you. I see there's another question about GitLab runners.
Is recommended use of shared public runners?
Can shared GitLab runners guarantee sensitive information is cleaned up, for example, credentials that are needed at runtime? So besides the caching, I mean, if you didn't define any caching, all the data will be deleted. You can, I think the cleanup was also part of the workshop, wasn't it? So if you're looking for a specific cleanup that needs to happen after each job run because you want to, for example, clean up the cache, you can do that and define it manually, but all of the credentials will not be shared within the runs as if they are part of like the CI/CD variables. But of course, if they're part of the variables, subsequent runs within the same pipeline will also have access to those secrets and pipelines. But only defined caching will be used throughout the runners.
Another thing you can do is use the built-in CI variables, and then you mark the variables as protected and masked. And then there's no 100% guarantee that when those ephemeral environments goes down, that all to be wiped down. But if you set those environments as protected at mass, that will help you keep them secure.
That's a very good link that Florian just said. Do you want to like voice it? I think that's an important point also in regards of the other question with the shared public runners.
Yeah, sure. So basically what happens is that all of these runners, they are run in ephemeral VMs, and they will be destroyed once you're done using them.
So you can use public runners without being worried that any of the data can be used by someone else also using public runners.
Yeah. Again, even if you're using SaaS, it's still possible for you to attach your own runners. So you're not limited to the GitLab hosted ones.
Yeah.
There's another question. Will there be any impact on the pipeline job speed if we use GitLab SaaS compared to the self-managed where the runners and the GitLab server will be in the same network? Well, the same applies for GitLab.com. So if you're hosting on GitLab.com, the runners are also within the same network, so you will not see any difference compared to the speed. If you are using the SaaS version with self-managed runners, there might be some latencies depending on where you host the runners. But we're talking rather milliseconds and seconds.
Yeah.
Just keep in mind, if you're using self-managed runners, you are in charge of all performance issues. So if you're experiencing any issues or might need to increase the CPU and GPU, but it also gives you the freedom to do so. So if you want like a heavier runner, you can do so using the self-managed runners.
Remember that you can always use the self-managed runner with the SaaS GitLab. So you can attach to GitLab.com GitLab and your on-prem runner. So you can always do this. So
yes, very important point. Yes, you can mix and match. So if you have certain jobs that are easy to, you can just use the self-hosted runners. If you have special requirements, for example, access to a registry that is hosted within your VPN, you can use a self-hosted runner just for that job. So you mix and match whatever suits the use case you have. No other open questions. If there's anything, I mean, you can also feel free to reach out. Maybe we can share the feedback link, Francesco, now that everyone is still here.
Yeah.
Would be very helpful for us if you take a few, I think it's 1 or 2 minutes max, to fill out the feedback issue. We will also share the link in the chat. I don't have it at hand, but I'll.
Yeah, I'm gonna
Also,
share it.
if you want, add us on LinkedIn and reach out.
Yeah, why not?
So yes, please go ahead, fill out the form. It's very helpful for us to understand if the content is relevant for you, if there's anything else that you feel like should have been covered, if you have ideas for future workshops and all of that. Just would appreciate if you take the time for feedback to us as well. The recording will be sent out together with the presentation, I think tomorrow or the day after, depending on when the recording is made available to us.
So
but you will
email.
receive it, yes, via email through the email address you've signed up with. And also the access for the lab will be available. I think is it 1 week or 2 weeks, Seraphine? You probably know best.
Oh, sorry. Access usually 2 days.
Oh,
it's 2 days. So
Wait,
it's on today. It's until the 2nd of March. I've also shared the link of the sample, the workshop itself, where it's being pulled up into this group. You can go there and clone the repo, and you can have access to other sessions there. Someone is asking, would there be any future sessions?
Yes, there are several sessions. We regularly host them. You can sign up. Let me share the link with you. There's an events page at gitlab.com. We also offer webinars and workshops around AI, for example, security, and other topics as well. Here is an overview to all of the... okay, I wanted to share another link, but I guess same. And you can just sign up. The structure is the same. You will always be provisioned with a custom Learn Lab, just as we did now. And then we will walk you through the content and answer any questions and answers.
Great. I think if there are no other questions, we can also give you some time back, right? So we finished a bit early, which is also fine. So I guess enjoy your lunch. Thank you all for coming in, listening, being so engaged with us. It's always fun to get questions. And yeah, I hope that we'll see you again at some of these webinars.
Thank you, everybody. Have a nice day, and see you in the next webinar. And thanks, Sarah and Florian.
Yeah, thank
and
you.
Sarah and Marcus.
Yeah, thank you all. Have a great day. Bye.
Bye-bye.